Okay, so what if we just have a function by itself and we're not given another function to check to see if they're inverses? We just have to find the inverse of the first function. So there are some steps we can follow to help us find inverse functions. So we're going to assuming that our function is one-to-one and that the algebra is doable, so this is important, we should be able to do the algebra for this, you can find f inverse using the following. So we're going to solve this equation, y equals f of x, and then get x equals f inverse of y. So we'll talk about how we do this by replacing x with y and then solving for y. And so this is going to be our inverse function, and then we can check our work by composing them. All right, so you've probably seen this technique before. So number 4 says find the inverse function of f of x equals 4 plus 3x. So the first thing we're going to do is to replace f of x with y, right? Because those are the same. So we're going to be looking at y equals 4 plus 3x. That's the first step, just getting rid of the function notation and just using x and y. Because we're now going to switch x and y and then solve for y. Switch. So we're going to switch x and y, and then we're going to solve for y. So instead of y here, we're going to use x. 4 plus 3y. So we just switched x and y. Now we're going to solve for y. All right, so what does this mean? This new y is our inverse function. So we can say that f inverse of x is x minus 4 divided by 3. And how do we know that we did this correctly? Well, we can check our answers by composing. So we can find f inverse of f of x and also find f of f inverse of x, and we should have x as our final answer. So let's do first f inverse of f of x. So we're putting f of x on the inside. Okay. So now we want to plug in 4 plus 3x into our inverse function. And we get x, so this is promising. We composed two functions and we got out exactly what we put in. Okay, now let's go the opposite way. Let's find f of f inverse of x. So this time the f inverse goes on the inside. So this is f inverse. All right, and so plugging in x minus 4 over 3 into our original, perfect. These 3's are going to cancel. Positive 4 minus 4. Perfect. We got exactly what we wanted, so this is indeed our inverse function of our original. Okay, so let's talk about how to use a table or a graph to compute inverse function values. Okay, so it says use a table for the one-to-one function f of x to compute each expression. So the table is like normal. We have an x it's like a horizontal XY table. We have our X values, 2, 3, 7, 6, 15, and our Y values, -1, 5, 4, 2, 3. And so we want to figure out F inverse of 5. So one thing I want us to remember is, how do we go and find inverse functions? We switch X and Y. So this thing in here, this 5, is not an X value. It's actually a Y value because we always switch X and Y for inverses. So remember, the input of F inverse is actually the Y value. And the output is the X. So again, switching X and Y. So when we're talking about F inverse of 5, this 5 is a Y value. So we want to look at our chart, start with the Y values, and figure out what X values it corresponds to. So we're looking at Y value 5, it goes with X value 3. So F inverse of 5 is 3. So the answer to an F inverse problem is actually an X value. So remember, it's the opposite. Okay. Now let's find F inverse of -1. Remember, -1 is a Y value. So we can look at the Y values on our table. F inverse of -1 is 2. All right, I'll let you do the last one and you can check your answer with me. F inverse of 2 is 6. All right, so make sure that you can determine if a function is one-to-one algebraically and graphically. So remember the horizontal line test. Are you able to determine the inverse of a function, switch X and Y? And can you figure out the domain and range of an inverse function? Remember, they're just the opposite of the original. All right, feel free to ask me these questions in class.